That's the whole.
Only in rock like this.
Thank you, thank you. Thank you. Thank you. Thank you. So let's go over these problems, the first few here pretty quickly. So a couple of things that I want to point out, because I saw this language showing up pretty regularly, and this is good. Well, first off, what are the coordinates for the pre-image and the image in 2.1?
7,
A is 7, 11.
8 and 7.
And then,
B is
8, 7.
8, 7, 4, 4, 14, 4, 3, 2.
Okay.
And then there's negative 4.
Sorry, I have a lot of conversations going on that aren't helping other people learn and are just distracting others. Okay.
But turn around.
So Josh, what is A prime again? What's A prime?
Is that right there?
That's not A prime. I don't have A prime up on the board yet.
Negative 11, comma 7.
Negative 11, comma 7. Also be careful, is that correct?
No.
What am I missing?
Parentheses.
Gotta have those parentheses, okay?
Oh, parentheses.
Hey, group 3. Up here, right now. Okay. Michaela, what's B prime?
Oh, negative 7.
B prime. Negative 7,
8.
8. Okay. Alright, what's C prime?
Negative 4, 14.
Negative 4, comma 14. London, B prime. Negative 2, parentheses 3. Parentheses 3. Comma, okay? Austin, I can hear your whine all the way over here. I need you to pay attention. Michaela, focus on this for a second, okay? Say it again. Okay. I thought y'all were talking to each other. Okay, but I need us to focus on this up here. So, couple of things I want to point out. I need everyone's attention, and if you don't already have these notes, I need you to now write these notes. Ren, what is something that you and your group talked about when we rotate 90 degrees counterclockwise?
That's the X and Y axis split.
Okay, so X and Y axis flipped. Do we all agree, or is there any part of that language we want to push on?
Missing the negative part.
So it's not quite a reflection. That reflections are kind of tied to it, but remember it is a rotation, and so we wouldn't say flipped here. They switch maybe.
The X axis becomes negative. You want the X value.
I need say that one more time.
The X value.
Okay, we need to be careful about this. I need you to pay attention to it. This is the y-axis. This is the x-axis. Is that what we have in the coordinate point?
No.
We have an
We have the
x
X
value or an x coordinate. You got to be careful about that. The x and y values switched. I also heard some language about what was happening to the x values. Someone other than Zari, she already talked, Ren already talked, Kelsey? Okay, so the x values are now negative?
No.
Does anyone want to push on that at all?
They're opposite.
Oh,
Yeah.
so it's not just always negative, you think it's going to be an opposite?
Yes.
This is an important distinction, right? The new x value, now is it going to be the opposite of the original x value or the opposite of what?
No.
The original
Y.
y value. That's important to notice, right? The x values are now the opposite.
Of the X. No.
How would I indicate that it's the previous y value?
The pre-image.
There we go. X values are now the opposite of the pre-image y value. That is fantastic language, right? X values are now the opposite of the pre-image y value, right? The new x value is now the opposite of the original, the pre-image's y value. Now, there's two things I want to look at in regards to this. You will only ever have to know the 90-degree rules. I don't remember if it was someone in group 3 or in group 7 who was asking about this, but there was a group who was asking, well, could there be something other than 90 degrees? Was that Austin? Okay. And that's a great question. Could I rotate something 30 degrees?
Yes.
100%. Could I rotate something 55 degrees?
Yes.
What about, I don't know, 1,000 degrees?
Yes.
It would just keep rotating. Here's the thing though. I will never ask you to know the rotation other than a 90-degree rotation. Because there is a very clear pattern with 90 degrees. And here is why. I do want you to make these notes, because this will be helpful later on. So remember, we originally had 3, 2. And I know some of y'all are not liking the scale, but we needed the scale in order to fit everything on here. 14, 4, 8, 7, and 7, 11. So I believe it looks like this. Does that look right?
Yeah.
Yes.
Okay. And then negative 11, 7. Oh, 7 be there. Okay. Negative 7, 8. And negative 4, 14. And negative 2, 3. So here's our new image. Now I do want to ask this, do those look pretty similar?
Yes. It's just on the different side, like.
There's on different sides. Does anyone have an idea what we might call these images? They are rotations, but
Flip slope. I don't know.
well, be careful, not a reflection, because it's literally a rotation, right? But I'm not talking about the transformation. I'm talking about, anyone have an idea what this shape and this shape might be to each
A
other?
square.
Say it again. Congruent. Do you think that they might have the same angles and same side lengths and same points? Literally, I took that and I just rotated it, right? That's important. Now, I want everyone to notice this, or this detail. This is what I want you to make a note about. I'm going to focus on just these 2 points right here. What is the slope of that line segment that I just drew? So I went up 2 to the right 3, so the slope would be 2 divided by 3. Right? That's this slope right there. Now, in contrast to that, what is the slope of that line segment?
Up 3 to the right.
It's up 3 and to the right 2?
No, left.
To the left 2, so negative? Anyone notice anything about those line segments?
Yes.
They see the bottom.
They're flipped.
Perpendicular.
Say that one more time about those line segments?
Perpendicular.
Oh, why would they be perpendicular?
Because they're,
So those slopes, are they opposites? One
Yes.
positive, one negative?
Yeah.
Are they reciprocals?
Yes.
Yes? Hey, what was the angle that we rotated at?
at 90-degree angle.
Oh, so we rotated a 90-degree angle. That is why the x and the y are flipping like that, because the only way to get those perpendicular line segments is for the x and y to switch. And for one of them to become the opposite. Okay? So I want you to notice and make a note to yourself here. The x and y values switch when rotating how many degrees? Rotating 90 degrees only. The x and the y values switch when rotating 90 degrees only because we are creating, what is that symbol? Perpendicular, right? The x and y values switch when rotating 90 degrees only because we're creating perpendicular line segments. That is a big, big deal to notice. So, if you rotate 30 degrees, are the x and y going to switch like that?
No.
I don't think so. In order to get it to rotate 30 degrees, you'll either have to get out a protractor and measure it, or you would have to use a calculator or a computer system. Okay? So that is what we want to notice. The x and y values switch when rotating 90 degrees only because they're creating perpendicular line segments. Now, did anyone notice which direction we were rotating 90 degrees?
South.
South.
To the left.
Not clockwise, it's called
Counterclockwise.
counterclockwise. You will see me and most mathematicians write this to indicate counterclockwise. Any guesses?
A 90%.
C, C, W.
Oh.
Counterclockwise.
Oh,
What would I put if it was clockwise? CW, right? So, make a note to yourself, CCW, that's counterclockwise, CW, that is clockwise. You will see me and other mathematicians, which you are now a mathematician because you're in my class,
Oh, yeah.
right? Mathematicians use CCW, counterclockwise, and CW for clockwise.
So either way it go, it's still clockwise. Well, no, it's not, because that's counterclockwise, and it's
So let's make sure we understand this difference. So if I have this circle, which direction, and let's say I'm starting here, which direction is counterclockwise? I'm going to go up and in the opposite direction. That is counterclockwise, whereas
clockwise is the other way.
so
If you
literally
start
going in the
down.
order of a clock. That is why it's called that. But it is going in either the order of a clock, clockwise, or going against the direction of a clock, counterclockwise.
Okay.
So, this is an important question. Do you think a 90-degree clockwise would act exactly
No.
the same way?
No.
Do you might think it might be similar?
Yes.
Very much so. But it is important to notice they are not going to be exactly the same. And we're going to talk about it because it is easy to notice the x and y value switching. The positive versus negative is not as easy, and so we're going to talk about it in a little bit of what to do when we run into that. So let's look at the next part about 180 degrees. All right. Oh. Can I erase all of this over here?
Yes.
Everybody writing
Yes.
or done writing over there? Okay. So E, what are the coordinates of E on 2.2?
5, 8, parentheses 5, 8.
Parentheses 5, 8.
Parentheses 10, 12. Parentheses 14.
Wait, 5, 8 or 5, 9?
I got 5'8".
Parentheses, oh, there's 2.
Is there
It's 14.
some debate about whether it's 5, 8 or 5, 9?
I got 5'8".
I got 5, 8.
got 5, 9.
Alright, let's
Go
check.
back to the picture.
Thank you. There we go. We don't have to make it complicated.
I got 5, 8.
Which ones are debate about?
It's E.
5'8"
It's
and
5'9".
Yeah.
5, 9. I got 5, 8. I ain't
So actions. Remember coordinates and equations.
Come on.
5'9".
5'9".
Oh, my calculator said 5, 8. My bad.
So be careful, check it. Alright, so we are looking at 5'9".
Yeah, but mine said 5, 8.
It's not 5'8". It is 5'9". I was trusting y'all.
14.
It said 13.
14.
Oh, mine said
14, 13, 4.
13,
14, 14.
Can I hear
It's
one
14,
person say, because I hear multiple saying it out loud right now. Shh. Rose. 14, 4?
No, it's 14, 3.
I got 14.
14, 3?
On the calculator, it said 14, 3, bro.
I got
Yeah,
14.
14, 3.
It's 14, 3.
I got 14. 2. Oh,
The other one is 10, 13.
Then it's
14, 3. And then what?
4, 6.
5. Oh, that's 4, 6.
4, 6.
I got 4,
But there's
5.
no way.
Wait, F is wrong.
F is wrong
F
also.
is 10, 13.
It's 10, 13.
Y'all stressing me.
Gotta go to the.
Don't tell me all the wrong numbers.
No.
Oh my good.
So 5.
Where are these numbers coming from, bro? Y'all know these numbers that I ain't never seen on these.
Maybe not him.
Not too late.
Austin,
Yes, sir.
why do I hear your voice right now like that?
Cause he's talking.
Y'all need to train like you talk to, cause y'all keep saying talk to.
Well, I'm trying to teach. So. Alright, does that look right?
Yeah.
That's right, Chase?
I get
Yeah, I go to the.
Hold on a second. I'm trying to. This is an important part. No, this is an important part. So, quickly, I want to point this out to everybody. It asks us to rotate it 180 degrees counterclockwise. Do you think 180 degrees counterclockwise would be the same or different from clockwise?
The same. Wait,
Does anybody who
It's
said
different.
same want to give me a reason why?
No.
I say different.
So we think it's
Well, you
different?
say counterclockwise or clockwise?
Okay, so Alana, why do you think it's the same?
It's, I say different.
Because it'll be the same way because I don't know how to explain.
Okay, let's investigate it.
You
So,
are
hey,
reflecting it.
hold on. We need to be careful with this. Are we reflecting anything?
No.
No. We are definitely rotating, right?
It flips over. Oh.
So-
No, it's not. Wait, I don't know.
What were the coordinates that you got after rotating it 180 degrees counterclockwise? Give me E prime, Zaria.
-5, -9.
-5, -9. Matthew?
-10 and -13. Comma.
-13. Kyson?
-14 and -3.
Okay. And Alana?
-4, -3.
Okay. By the way, we didn't do this on the last one, but we really should also mark what each of these coordinates are. So like this would have been H, E,
Right.
I believe this one was F and G. Okay, so now we have -5, -9, -10. It's not time for you to worry about what time it is, it's time for you to learn some math. -14, -3.
Who you talk to?
You dropped some.
And so we have H prime. Yo, why do I hear you talking?
Well, shut up, cause you talk.
Yo. Yep, I will say this. There's only like a handful of students who could ever claim or talk about anyone else not knowing how to shut up. And usually those are the people who aren't talking at all. Like if I heard Jeremy go, man, you talk too much, I know that person's going overboard because that would require Jeremy to talk, right?
She just spoke.
Did he?
Asked
Good.
him to get a pencil, he said, I don't got one.
Alright. He's still crushing it, but like, if you are regularly talking when you shouldn't be talking, you can't call other people out. That's my point. So, I want to look at this really quickly, okay? Notice that's 180 degrees rotation over to here. We can follow it because we saw earlier that the 90 degrees, the X and Y what? Switched?
They switched for us.
And then, well, did both of the values become negative?
Yes.
No.
Wait, no.
Wait, yeah.
So first, hold on. Sorry, y'all are missing the question. When we did it 90 degrees earlier,
Oh.
did both of them become opposites?
Oh.
And also notice that language, did they become negative or opposites?
Negative.
Opposite.
Because here's the thing, if it was already negative, it would become the
Opposite.
opposite, which is positive. Okay, we need to be careful about that. So let's look at this really quickly. Let's actually look at what would happen if we went 90 degrees clockwise. This is why you need to have a pencil in hand and you need to take some notes. So if I were to go 90 degrees clockwise, have we done 90 degrees clockwise here?
No.
We have not. However, we know that the X and Y are going to have to what?
You're gonna have to swap.
They're going to have to swap. They're going to have to switch orders. So if this right here is 4, 6, when I rotate it clockwise, it's going to have to be what?
6, 4.
6, 4. So I'm going to go to the right 6, and then am I going to go up 4?
Down.
I have to go down 4?
Yes.
So let me ask you a question. Do we actually have to know which one's going to become negative if we know what quadrant it's going to be in?
Because if you
don't.
If you know the quadrant, you know it'll automatically.
There we go. And this is something I want you to notice. Because when I had to learn how to do this, I had to memorize every single one of these rules. And then I realized, and then the first year I taught geometry, I realized, oh wait, the x and y are always swapping or switching places. So if I know what quadrant it's going into, I don't have to memorize which one's negative and which one's positive. So that became 6, negative 4, and that is h. I'm going to call it double prime for now to indicate it's different than this one. So if this coordinate right here is 5, 9, what's it going to be when I rotate it 90 degrees clockwise? 9, 5. Except it's going to be to the right 9 and down 5. I just have to make sure it goes into the right quadrant. Right? And then there is E double prime. So from there, Amari, I have F here, which is 10, 13. If I rotate it 90 degrees clockwise, what do I know it has to become with those coordinates? You don't know?
Negative.
Have you been paying attention while we've been talking about this? How are you going to learn if you're not paying attention?
I was paying attention. What do you mean?
Okay, so can you tell us what we've just been talking about always happens with the x and y when we rotate 90 degrees? Amari, I'm not trying to call you out to make fun of you or anything like that. I'm trying to make sure that you are aware that you actually are not paying attention like you need to. It's hard to learn when you're not paying attention. Rose, what's going to happen to x and y? They're going to flip. They're going to switch orders. Now be careful about the word flip, because what does the word flip make you think of?
Up and
Turn
down.
over.
What transformation?
Reflection.
A reflection. So I don't want to use the word flip because I don't want you to think about a reflection. So Amari, what did Rose just say about those x and y values? They're going to what?
Swap.
They're going to what? Flip? Okay, but we don't want to say flip. We want to call it a swap or a switch. Because the word flip makes you think about a reflection. So instead of 10, 13, it's going to become 13, 10. Okay, so 13, and I know it's down 10. Y'all. And then G, which is currently 14, 3. Michaela, what are those coordinates going to become? It's going to be what? What are those coordinates going to become when I rotate 90 degrees clockwise?
Wait, is that a 3?
Say again. Then we come. Okay, both of them? So I get negative 3, negative 14?
No.
Come on, what have we said every time about the coordinates? They're going to what? Switch. So what's that going to become? 3, 14. But remember, it's not 3 to the right and up 14. It's 3 to the right. And we know because it's in this quadrant, it has to be down 14.
It's a little bit more line. I'd say this way.
So does that look like the same shape?
Yes.
Yeah. Now, this is where we want to pay attention. How many degrees do we just rotate?
90.
90. I still have how many more degrees to go 180? 90. So this point, right, it originally was 4, 6. Now it is 6, 6, negative 4 is 6, 4. So then when it comes back over to here, it's going to become what?
6, 4.
It's all, right now it's 6, 4.
4, 6.
Oh, so to the left 4 and down how far?
6.
So down 6. So does that get to the same point?
Yes.
This point that started out 5, 9 became 9, 5. And so when it rotates again, it's going to become negative 5, negative 9. So it went back to that 5, 9. Yes, no, maybe
Yes.
so. 10, 13 became 13 and 10, but I know it's negative because it's going down. Right? So Alicia, if I rotate it again, what's going to be? Is it going to be 13, 10, 10, 13, none of the above? You don't know? Okay, so I'm going to come back to you for the next one. Gabe, This 13, negative 10, what's it going to become if I rotate another 90 degrees?
10 and negative 13.
Okay, so
Negative 10, negative 13.
Hold on.
remember the big thing we need to notice is that the x and y are going to what? Switch. And then because it's in this quadrant, I know they're both negative. Remember, you don't have to memorize the negative. You just need to remember to switch the x and y, and then what quadrant it's in tells you whether it's negative or positive. Okay, so Lucy, I'm coming back to you. So 14, 3 switched and became 3 and 14, but where is it which one's positive, which one's negative?
Oh, wait.
This 14, 3 became a 3 and a 14, but which one's negative? The 14, right? It's going down. So then, Alicia, where is that? Is it going to be 3 and then 14, or 14 then 3 when I rotate again? 14 and 3. Are any of those going to be negative?
Yes.
Which ones?
Wait, hold on. What you mean? What, are both negative?
They're both. Remember, they're just in the third quadrant. They both have to be negative. That's all you got to do. So, again, and let's go back to the original question that led us here. First off, 90 degrees clockwise, is it similar?
Yes.
Yes, very much so, right?
Yes.
180 degrees clockwise, is that the same as 180 degrees
No.
counterclockwise?
No.
No.
Didn't we end up exactly where we did after the 180 degree counterclockwise?
Oh, yes.
So is 180 degrees counterclockwise the same as 180 degrees clockwise?
Yes.
Yeah.
Yeah? Hey, what's 180 degrees plus 180 degrees?
360.
Oh, so it's the same as a full circle, so it'd end up in the same
That's why
spot.
I keep rotating all around.
Right? So notice if I rotate this way or this way, it should be the same. Right?
Usually, I need 90.
That's a full circle's worth. Alright. Oh, so notes that we want to make here. 180 degrees counterclockwise is what to 180 degrees clockwise?
Congruent.
Not
Wait,
congruent,
equal.
Equal.
not equal,
What is that? Equal?
equivalent. Okay? When it is 3 lines, it's not equal to, it's not congruent. That is the equivalent, meaning it's different, but it's still the same.
So what's the difference between equal and equivalent?
So, that's a good question.
Equal is the equation, equivalent is not.
Hold on 1 second. No, partially. So 3x plus 4 is equal to 13. Are
Okay.
those exactly the same?
No.
No. Right? Those are not the same expression, but I am saying that they are equal to each other. Can I now solve for x and find what makes them equal?
Okay. So my x,
Okay.
you know, you at.
Now, if I were to have 3x plus 4, in this case, those look very
Same.
different to start, don't they?
Yeah.
Okay.
But if I distribute,
They'll look the same.
so even though they started out looking different, were they different?
No.
No.
No. So equivalent means they look different, but they are the same and they will always be the same. Equal is a statement between numbers that they can be equal to each other. They're not necessarily equivalent though.
Oh.
Does that help
Yes.
solidify that idea?
Wait, so that, wait, that
What's up?
I don't know what you're saying, Matthew.
Okay, explain stuff.
Say it one more time.
Isn't that like the same kind of definition of?
Kind of, but congruent specifically deals with geometric shapes. Okay? So for example, and this is actually a good question. Actually, I mean, we can look at it right here.
What is that?
What's that?
These, hey, how about you focus on your math, learning?
Okay, concentrate.
That's well. I'm losing burn cells.
So I want y'all to look again at this. Are these exactly the same right now?
Yes.
No.
Wait.
I mean, they're not. If they're exactly the same, they would be matched on top of each other,
No, they're not.
right? So they're not. But even though they look a little different, are they still the same shape?
Yes.
So that's kind of like the idea of congruence. It's a geometric version of equivalence, right? So they look different just because they're in different places and they're rotated, but could I take this and match it on top perfectly? Yes. Just like, could I take this and match them perfectly?
Yes.
So the idea of congruence is like a geometric version of equivalence.
So it has to do with shape.
Say again.
Is that different shapes?
Yes, congruence deals with geometric shapes and figures and all that kind of stuff. And so we'll actually define congruence a little bit better next unit. Okay? But there we go. Actually, we'll do it within the next lesson. But I want you to notice, again, 180 degrees counterclockwise is equivalent to 180 degrees clockwise. You need to have that note down.
Did you say the Bushy's due tomorrow?
No, I did not.
Okay, good.
I thought it was the computer.
Okay?
What's that for?
That's all right.
So, hey, yo, we have 10 minutes left. Give me your best 10 minutes to wrap this up well. I don't think most of us finished the 270 degrees counterclockwise, did we?
I did.
We did? No?
We did.
Some of us did? Or, okay. So, I know that most of us did not necessarily finish. Hey, why are we packing? We got 10 solid minutes. Solid minutes. Okay? Does anyone have an idea what rotation 270 degrees counterclockwise might be equivalent to?
120.
So let's
90 degrees? 90 degrees.
90 degrees.
Counterclockwise.
It's already counterclockwise. So notice if I take this and I rotate it around 270 degrees counterclockwise, couldn't I have just done 90 degrees clockwise?
Yeah.
So let me ask you this. Do you want to do 270 counterclockwise or just do 90 clockwise?
90 clockwise.
One of the best things about learning math well is that instead of doing the hard thing, do the easier. If I am ever asked to do 270 degrees counterclockwise, I'm doing 90 clockwise every single time. In a similar way, if I was asked to do 270 degrees clockwise, what would I do?
90 degrees counterclockwise.
Oh, I don't know what he said, but how about you focus on your learning?
God dang.
Do the easier version. Right? Do the easier version. That's the biggest thing that I want you to make a note of on 2.3. 270 degrees counterclockwise, hey, that's equivalent to 90 degrees clockwise. 270 degrees clockwise, hey, that's the same as 90 degrees counterclockwise. Do the easier version. Dude, we still have 8 minutes left. Like,
90 degrees counterclockwise. For 270 counterclockwise.
here's the last thing that I do want you to make a note of with this lesson. The last thing I want you to make a note of with this lesson is when rotating (90°), what do we know about the x and y?
They got X?
They switch.
Oh,
The x and
yeah,
y.
they switch.
The x and y values switch.
You right.
Notice, did I say anything about when it's the opposite or anything like that?
No.
So how are we going to know which one is negative or positive or anything like
The
that?
X's.
Okay, so pay attention to the
X.
quadrant, which is based on the axes, right? So to determine if positive or negative, pay attention to the quadrant. You know, or should know by now, that those x and y values are going to switch. You just need to pay attention to the quadrants going in to determine if it's positive or negative.
No, you distract me. I'm trying.
Alright. I am going to do a quick, hey, I'm going to send out a quick understanding check. We are not going to finish it. Hold on.
Dang.
You will not finish this understanding check. Do as much of it as you can. I will collect it and we will finish it tomorrow. So start your understanding check.
I ain't get it. Open up the calculator.
Turn on the calculator, dude.
Shit, I gotta get
Is-
said you gotta get rid of the name.
Huh?
it. New.
Don't save the old file, just
Hold
don't
on,
save.
what I do to this?
I just saw that.
Put this back in the bag.
Yeah. Literally, all you have to do is click on the open.
I did,
And then you don't save it. Do not.
Where do I go to? I gotta log back in.
Yeah, if you're not logged in, then you have to log back in. But it won't let you right now.
Okay.
You have to reset the calculator.
Do this, how we gonna do that too?
Oh wait, hold on. For some reason it didn't. I don't know why I put it there. There you go.
What is it?
Yep, that's it.